Good morning, good afternoon, good evening, good night. My name is Ben Riga. We're going to talk about some cool stuff this morning. As you can see, we'll be talking about all sorts of cool techniques and tips and tricks and anything related to how you can get your apps built in such a way that you can reuse as much of your code when you're building both Windows 8 and Windows Phone. Before I get started, let me introduce myself. My name is Ben Riga. I'm a technical evangelist at Microsoft. I'm in a group called Developer and Platform Evangelism, or DPE. I spent quite a bit of time on Windows Phone, about 3 years, and recently I've moved over to Windows 8, and so I've been thinking a lot about the overlap between Windows Phone and Windows 8, and so a lot of that learning and a lot of the things that have been going on over the past 6 to 9 months as we've been talking about Windows 8, we're going to talk about that today. If you want to follow me after this session, or if you want to get in touch with me either via email or Twitter or Facebook or Google Plus or whatever social network you're on, you can find me on about.me/ben.riga. And so go ahead and do that. Before we actually get into it, there's some cool stuff that the Microsoft Virtual Academy are doing, and so I wanted to highlight those. The first thing is there's a lot of interesting stuff going on around getting certified and getting training for certification. There's some interesting exams and training options that the MVA has put together, and so that short URL is there. There's also the MCSD exams and training information there. And if you're looking for training directly from Training Pros, the link is there for the certified training places, including finding a class near you wherever you might be in the world. As you can see, we're actually on the Microsoft Virtual Academy site today. There's a lot of interesting training that goes on this site, and so if this is your first time here, you'll want to join and take advantage of all this free online training. There is already over 1 million registered users, and if you want to stay up to date with all of the stuff that's going on at Microsoft training, whether it's server, client, phone, or any of that stuff, you can do that. And you can earn points for each of the events that you attend. In fact, you will get 50 MVA points for this event. In order to do that, the short URL is there. It's aka.ms/MVA voucher, and use the both W8 and WP8JS coupon code. That does expire, so please do go ahead and do that. Now, as I said, my name is Ben Riga, but there's a bunch of people behind the scenes that are helping me, as there are a lot more people on this event that I had expected, which is a great thing. But I needed some help to handle all the Q&A, and so some of the folks on my team, my team leader, Drew Robbins, as well as a smart guy named Jaime Rodriguez, and one of the new members on our team, Nisha Singh, they'll be behind the scenes answering all your Q&A, so if you ask questions in the chat window and they magically get answered, it's probably one of them that's doing it. And also, there's a couple of people that helped out with this content that were not able to attend this event, Andrew Byrne and Matthias Shapiro, that helped review content and so on. And so they're actually pretty smart in this area, and so they might be good people that you might want to follow on Twitter. So who are we looking for, or who are we trying to help with this content? Obviously, it's developer-related content, but the developers I think that'll get the most benefit from this content is developers that are perhaps already Windows Phone developers, and so perhaps you already have an app in the Windows Phone Marketplace, and you're thinking about, or perhaps have already started moving that Windows Phone 7 app to Windows Phone 8. And so what we'd like to do is make it easier for you to develop for Windows Phone 8 and at the same time develop your Windows 8 app and get that out there. And obviously, as part of doing that, that expands the reach that your app would have by obviously addressing those two different markets with hopefully a lot of the same code. So what should you expect from this session? It is a 4-hour session, and I'll talk about what's in that. After you leave this session, you should have a really good understanding of the similarities and differences between Windows 8 and Windows Phone, and specifically Windows Phone 8. And you should have a really good understanding of all the tips and tricks and techniques and patterns and all of that good stuff related to how you can build for both Windows Phone 8 and Windows 8, as well as you're doing that, maximize the amount of code that you reuse when you're doing that. The presentation doesn't really cover how to start building a Windows Phone app or how to build a Windows 8 app. There's lots of really good content, including on the MVA site. There's lots of really good content of how to learn how to begin development for Windows Phone or for Windows 8. That's not what we're going to do today. We're kind of assuming that you have a pretty good grounding in Windows Phone and hopefully Windows 8 development as well. And what we're going to try and do is help you merge the two or bridge the two together. There is also no way for you to build an app that runs on both Windows Phone and Windows 8. That is not a concept, and so hopefully you're not expecting to do that. It's just not possible at this point. So why are we doing this? Obviously, Windows Phone and Windows, you'll hopefully by the end of this session, you'll see that they're sort of on this convergence path. There's lots of really good stuff that the Windows Phone team had done, and then the Windows 8 team has sort of jumped over that and gone way beyond, and at the same time the Windows Phone team have taken as much of that as they possibly could into Windows Phone 8. And ultimately what that means is that we're on this sort of path to Windows Phone and Windows 8 converging. Now, they're not there yet, obviously. They are still two different platforms, I would even say two very different platforms, but there are a lot of similarities, and that's what we're going to focus on today. You may have already seen this sort of high-level architecture slide of what the Windows 8 platform is. Obviously, there's the apps, the desktop apps that you may have been building in the past, whether it's C# or C++ or so on. We're obviously going to focus on Windows Store apps. That's where as Microsoft, we're focusing a lot of our energies there, obviously. And actually, we're also going to be very focused on the XAML part of Windows Store. And in fact, we'll be spending all of our time using C#, because that is an easy overlap between Windows Phone and Windows 8. Specifically, there are some parts of the Windows Runtime APIs, the WinRT APIs, and so there are quite a few different APIs, and so we'll talk about all of the various areas. Obviously, in 4 hours, we can't cover everything in detail, but like I said, by the time you leave, you'll have a really good idea of the similarities and differences between those two. When you think about Windows Phone, or specifically Windows Phone 7, and like I said, I'm hoping that many of you have already built Windows Phone 7 apps. In the past, that was all about .NET, C#, VB, C# or VB. When we moved to Windows Phone 8, obviously, there was a runtime as well that we've now added, which can be used from either C# VB, and with Windows Phone 8, we've added C++ as well. And finally, if you are especially if you need to talk directly to the metal, things like Direct3D, Xaudio, all of that good stuff, you can actually do that, obviously, but you would do that with C++. What we're going to focus on today is really the C#. Now, the Windows Phone APIs, there's all sorts of other APIs that are over and above the Windows Runtime APIs, and of course, you can still continue to use those, but those don't help you when you're trying to bridge the two different platforms. And so what we're going to focus on is where the two platforms intersect. And this is sort of a general sort of high-level view. As you can imagine, the Windows runtime is quite large, and the Windows Phone runtime is also quite large and has some things over and above what the Windows 8 runtime has. But there are certain areas where, if you're very careful, you can actually build your code in such a way that you can actually reuse it across both those platforms. So let's talk about what we're going to talk about over the next 4 hours. I've split the session into 4 areas. The first one, we'll talk about the similarities and differences between Windows Phone 8 and Windows 8, sort of comparing and contrasting the two. We'll talk about the UI. We'll talk about data models and so on. And then there's some things that you probably should know. Many of you may already be using MVVM, but I do know that there are many that still are not using MVVM, and so I wanted to dive in and look at some of the things that you need to do to move your apps from non-MVVM to MVVM. And the reason for that is by using a pattern like MVVM, and for those of you that don't know what MVVM is, we'll go into that in a lot of detail later on. But it is a really good pattern for code reusability. And basically what it means is you'd be separating the concerns. You'd be separating your data from your view model from your view, or what your UI is. And then finally, when we have that good base between the similarities and differences and this pattern of MVVM, then we'll talk about some very specific techniques that you can use to maximize that code reuse. Let's look at those things in a little bit more detail. As I said, when you think about Windows 8 and Windows Phone 8, there are some things that you'll be thinking about. The first one, it's sort of optically, the first thing you think about is the UI. Visually, Windows 8 and Windows Phone 8 look very similar, and so you want to think about that, and we'll talk about what the differences are there. There's also, under the covers, you're probably, unless it's a very trivial app, you're probably using data of some sort. And data is probably one of the easiest things that you can reuse across both Windows Phone and Windows 8, and so we'll talk about some of those things. And then finally, we'll get into some of the platform-specific features that are across both platforms, and that sort of at first glance you would think would be portable or reusable, but when you get into it, maybe is a little bit more difficult. We'll talk about all of those things later on. As I said, the basics of MVVM rely on the VM part, the view model part, and so we'll talk about what that means, and we'll dive into data binding. Maybe you're already using data binding. We'll talk about what's going on under the hood and why data binding actually works, and it is sort of the linchpin, or the thing that sort of makes MVVM pretty cool, I think. When we talk about MVVM itself, we'll get into an introduction of what that means, the model view model. We'll talk about the architecture, the pros and cons, and then we'll talk about how, by using MVVM, you can reuse a lot of your code. And then finally, we'll touch briefly on some of the third-party libraries that are already out there that help you over and above the sort of basics that you can do on your own. And then, as I said, once we have that base, we'll talk about how to share code. And there we'll talk about things like portable class libraries, sharing source code between projects and solutions, inheritance, conditional compilation, and then finally partial classes and methods. And so with that, I think we should just dive in. The first step, as I said, is we're going to talk about comparing Windows 8 and Windows Phone 8, and so that's our first stop in this journey. We've already seen the agenda, so let's just jump right in. The first thing when you think about Windows 8 and Windows Phone 8 is the UI. As I said, they do look very different. Windows Phone with the live tiles and Windows 8 with their its live tiles, they're actually very similar. And so you would expect that some of that sort of transfers over. And obviously, there is a lot of inspiration and innovation going on between the two teams. You see one team building on the other, and then the other one leapfrogging, and so on. But there are some very dramatic differences that you have to keep in mind. Windows Phone 8 really comes in three different form factors: 800 by 480, 1280 by 720, and 1280 by 768. And Windows 8 comes in many form factors. Basically, it's 1024 by 768 as a minimum, but then there really is no maximum. You can go to all sorts of different wild and wonderful screen sizes and so on, including multiple screens and all of that good stuff. When you think of Windows Phone, you can use a Windows Phone in portrait and landscape, but for the most part, most of the apps and the device itself is sort of built to be used in a portrait form. And it's not a requirement. Obviously, many apps do use the landscape form factor, but for all intents and purposes, you're using your thumb to scroll and so on, and so the portrait is sort of the predominant one. And obviously, the screen sizes for Windows Phone are going to be much smaller. It's got to fit in your pocket. And so screen sizes, I think the largest screen size right now is 4.7 or 4.8 inches. Windows 8, a little different there. It is designed to be used in a landscape form. The tiles, for instance, on the side, on the start screen actually scroll horizontally. A lot of the content when you're scrolling it is scrolling horizontally, and so it's a different feel, and it's built differently from that perspective. There are also other types of form factors that you have to think about in Windows 8. You can look at Windows 8 in a portrait. If you turn your slate, for instance, it should snap into a portrait form. And then there's also the snap view, the smaller screen along the left-hand side, and then the filled view, which is the remainder of the screen when you are using that snap view. And as I said earlier, there's lots of different screen sizes. Pretty much you start at 10 inches and go up to, I've seen 80 inches and higher. So with that in mind, there are some user experience considerations that you have to keep in mind. You, of course, are trying to design a native UX for that platform. It should feel like a native UX, and so you want to keep that in what's native for that platform in mind as you're doing that. The first thing is Windows Phone, as I said, is portrait. It's really designed to be used in a one-handed way with one-handed touch. You pull your phone out of your pocket and you're scrolling and typing and so on one-handed. Windows 8 as a tablet is meant to be held with two hands. It can be used with one hand, of course, but can also be used with a mouse and with ink and other things, so you have to keep those in mind. Windows Phone 8 has some very specific requirements that the OEMs have to fulfill if they build a Windows Phone 8 device. And so as a developer, you're guaranteed to have specific hardware. Things like camera and accelerometer, sort of, they'll be there. There is no guarantee of specific hardware in a Windows 8 device. There are certain things that, of course, you can rely on, but you really have to check at runtime whether that specific feature you need is actually available on the device that the end user has installed your app on. On Windows Phone, because of the form factor, you tend to avoid multiple columns of data. It's not a requirement, but it's kind of hard to do on smaller screens. And in Windows 8, you're almost guaranteed to have lots of columns just because the screens are big and you want to organize the data in that way. I mentioned this earlier. Windows Phone is really meant, in many cases, you're scrolling up and down for more content. And Windows 8, you're scrolling left to right. Windows Phone 8, there's very limited room for the OS to do menuing or choosing of options. And so the app bar tends to be very small. There's only 4 items. And so you have very limited room on there. Windows 8, there's significantly more room. In fact, you have 2 app bars. You can have a bottom and a top app bar. And within that, there's a lot of room to put any sort of containers with commanding and so on. On Windows Phone, you are guaranteed to have a back button. There is a hardware back button on every Windows Phone device. There is no hardware back button on Windows 8, but there is an on-screen back button that you have to be aware of. Windows 8 also has the concept of semantic zoom. It's a key part of the experience, and Windows Phone 8 doesn't have anything like that, and so you have to keep that in mind. So with that, if you keep that in mind, you think about the things like form factor and the user experience consideration, the advice that I would give you is don't try and reuse your XAML across Windows Phone and Windows 8. Of course, it still is XAML, and you can reuse all of your skills, and you may even be able to reuse some controls and so on. But for the most part, you really want to design your apps with different views, with different designs, with different user experiences, whether you're doing a small screen or a large screen. And that's related to a few things. Some of the things that we talked about, the experience, the screen space, the page layout, and the orientation, the stuff we just talked about, but also things like the XAML namespaces and XAML controls. And by that, let's talk about that. So there are obviously a huge overlap between controls and the two platforms, and yet the namespaces between them are not always the same. In fact, many times they're not. And so you have to, as you're building your XAML views, it just becomes very hard and very cumbersome when you're changing namespaces and so on. It just becomes a bit of a chore and a kind of a nightmare when you're doing that. Many controls are present on both platforms, but they're, as I said, in different namespaces. And so things like the windows.ui.xaml.controls.canvas versus system.windows.control.canvas on Windows Phone 8. And then, of course, there are some controls that are just not supported on the other platforms. So the pivot is a perfect example of that. It's a control that was designed specifically for Windows Phone, and so the Windows 8 team chose not to implement that, and it probably didn't make sense to implement that on Windows 8, and so if you try to use that, you'll have some issues. There is a much more detailed comparison of the controls between Windows 8 and Windows Phone 8 that the Windows Phone team, documentation team put together. The URL is down at the bottom of the screen there. Don't try and grab it now. Actually, at the end of this event, I'll have a list of all the resources that are available in one place, so you can go and grab it all at the same time, and we'll talk about that later. As I said, each platform has its own set of XAML controls. There is some, but not much overlap between the two. Some controls are available on both platforms, but they don't overlap. And just some examples, for instance, things like Windows Phone uses the phone application page as the root page element, and Windows 8, its page as the root page element. Windows Phone 8, you use the long list selector to show vertical scrolling of content. On Windows 8, you use the list view to scroll, and it actually scrolls vertically or horizontally as well. You also have the pivot control for paging content horizontally or for tabbing of content. In Windows 8, you have the flip view for paging of content horizontally. Windows Phone 8 has the application bar control. Windows 8 has the app bar control. And then Windows 8 also has a grid view to group content in a grid on the display in the layout. So if you look at Windows 8 controls, most of the templates that you start with in Windows 8 in Visual Studio start off with a layout aware page that then gives you things like a grid view. Then you can add an app bar, the list view control, the flip view control. These are all standard controls that are optimized for the Windows 8 platform. And then in many cases, in fact, in all cases, these controls are just not available on Windows Phone. And so if you're building on that, if you're trying to build with controls that are available on both, you're building to a very limited set of controls, in fact. This is just an example of Windows Phone controls here, where you have 2 pages. You have 2 pivot pages on a pivot control. There's the long list selector with the content that's scrolling vertically, and then you have the application bar control. Again, these controls are optimized for Windows Phone, and so you should focus your efforts on optimizing your user experience for that platform. So we've talked about the user experience, or the UI of the experience, and as I said, you're probably not going to gain a lot of reuse on the UI, and for most purposes, you probably don't want to try and reuse that. On the opposite end of the spectrum is the data model. That's where all your data is stored, and there you can actually benefit greatly by reusing code whenever you can. And so let's talk about what that means. First of all, I certainly encourage you, if you're not already doing that, to sort of group all of your data together in a data model, or your data access into a data model, so that it makes it easier to understand your code, to structure your code. It makes it more modular, makes it easier to debug and to test, and it makes it easier to find what you're looking for when you're looking for it. The most important part from our perspective today for this course is that by putting your data into a data model, it makes it more portable across Windows Phone and Windows 8, because you can leverage the APIs that are portable between those two and do it in one area, and then port that between Windows 8 and Windows Phone 8. And we'll talk about how you do that later. But right now I want to talk about storage in general. So Windows 8 and Windows Phone 8 both support storage of key value pairs, settings, files, and folders, and so on. all of that storage is isolated, so any app, whether it's on Windows 8 or Windows Phone 8, cannot see any other app on that platform, on that PC. And that's just for security and for isolation purposes and so on. Windows Phone 8 also supports SQL CE. It's standard and to the platform. Windows 8 does not have a built-in Microsoft SQL database. On the other hand, there are readily available SQLite libraries that you can go and download and take advantage of, and many developers are doing that. There are shared APIs in the Windows.Storage namespace, and so by taking advantage of those, you can actually manage local app storage in a way that is portable between Windows Phone and Windows 8. And here you're using a lot of the async and await capabilities that were introduced with Windows 8. The Windows Phone APIs are a subset of the full APIs, and so not all of the Windows 8 Windows.Storage namespace, for instance, not all of those APIs are available. For instance, there is no roaming of data store, temporary data store local settings, and roaming of settings. All of that stuff is not available to you on Windows Phone. And so we wanted to talk about what is available and what are some of the things that you can take advantage of. As I said, the Windows.Storage, for the purposes of local app file storage, both Windows Phone 8 and Windows 8 support that namespace and some of the things that are in there. We'll talk about what that means in a second, and we'll get to a demo, and I'll show you how we do that. There is system.io isolated storage and isolated storage file. This is something that you have on Windows Phone 8. And you can use that. You can continue to use that in Windows Phone 8 and Windows Phone 7 for that matter. But my recommendation to you is start moving to Windows.Storage. We haven't deprecated system.io or anything like that, but you would imagine that over time we will put more of our efforts into Windows.Storage, and it obviously behooves you to take advantage of that because it is portable between those two platforms. And so if you start moving over there, the sooner you start moving over there, the better it is for your app. And then when you're storing your application data settings, you would use application data, also in Windows.Storage, but it is available only on Windows 8. And that's, again, just standard key value storage where you would use that for your settings, both local settings or roaming of settings. And then in Windows Phone, the way to do that is system.io.isolated storage. Unfortunately, that is not portable, and so on. And then, as I mentioned earlier, there is no SQL database. There is SQL CE on Windows Phone 8. That's standard part of the platform. Windows 8 does not include that, but you do have access via open source, the SQLite libraries, as I mentioned. It's a big search away to grab that. So I've been talking for quite a while. Let's stop for a second and take a look at a demo. And so let me see here. Let me just move over to Visual Studio. So I have I'm going to be using two apps today for demos, two, maybe three actually. The first one is the Contoso Cookbook. It's, if you've done any Windows 8, any of the Windows 8 hands-on labs, it's used throughout. It's a really great sample, and I certainly encourage you to spend some time with it. And also with Windows Phone 8, there was a hands-on lab that was built with the Contoso Cookbook, and so that app was actually ported to Windows Phone 8. And so it's a really good example of how to do things on Windows 8 and then how to take that to Windows Phone 8. And so it gives you something you can compare and contrast. And then later on, I'll use another app that was developed. You may have seen it. It's called PixPresenter or Photo Manager. And so we'll look at that one later when we get into the code reuse. That one was actually built to show off code reuse between the two platforms, and so we'll take advantage of that. And both of those are available on the internet. Again, I'll give you a list of all of the various resources that I'm using today, including MSDN pages that are useful and so on. Okay, so let's actually stop talking and start looking at some code. So I've actually opened up, you can see here I have the Contoso Cookbook Windows 8 version. And so in this case, let me go over to Common, and in the Common folder, there is something called Suspension Manager. Oh, I had it open already. And so I'm going to go over to the Save Async. And so I'm using this not so much because we're talking about suspending and so on, or lifecycle management of apps. What I'm using it for is just to give you a sense of how you would do things like storing of files and so on. We will talk about lifecycle in a few minutes, though. So here I'm using save async, and if we look here, you can see how, let me, hopefully you guys can see this, how I'm serializing the session state here asynchronously using memory stream. You can see here I'm newing up a new memory stream, and then I'm using the data contract serializer, which takes that a dictionary and serializes it into a XML form. And so here's my serializer, which I'm writing to this memory stream. And now once I have this memory stream, here's the guts of it. Here is the storage file I'm newing up, and here I'm actually creating file async. And once I've done that, I can use my file stream to then, where is it? Here, copy to async. So I'm just using the standard Windows.storage APIs to take advantage. I'm taking advantage of those to actually very quickly and easily move my data, my session data in this case, from memory into to my local storage. And then finally I do a flush async. And then when I want to bring it back, there's the restore async method here, which essentially does the same thing in reverse, where I now open up my session state file name, and file name is just the standard, underscore session state.xml. And so there I'm opening up my file, and then using my stream, I'm opening up the stream and then deserializing it again using the data contract serializer, and then from that I have my session state, and then I'm registering frames and so on and bringing them back to their save state. This is the way we do it in Windows 8. This same code would run pretty much the same way in Windows Phone 8. Now, of course, you wouldn't be doing this sort of suspension management in Windows Phone 8 because the suspension man is different. But for the purposes of reading and writing to files, the code is pretty much the same. And so, as a result, it's perfectly portable between the two platforms, and you should take advantage of that. So if you are still using the Windows Phone isolated storage APIs, I would encourage you to start thinking about moving to the Windows.storage APIs. All right, let's head back to PowerPoint. How are we doing on questions, Frank? Are we doing good? Are there a lot of people online? Frank's not listening. Not seeing any questions. No? Okay, let's just keep going. Okay, so you are using Windows.storage, as I mentioned, and so if you are using Windows.storage, then that is portable between the two platforms, and as a result, there are certain things that you can take advantage of. We're going to go into these in a lot more detail in the final session of the course today, but things like portable libraries, portable class libraries, that is, sharing of let me try again, sharing of source code between projects and solutions, inheritance, software patterns like I talked about earlier, MVVM. We'll go into that in a lot more detail earlier. And then I would say almost as a last resort, conditional blocks. Conditional blocks, well, we'll talk about all those in a sense later. Your data model and hopefully, for the most part, your business logic should be largely reusable among your two platforms if you take advantage of the right APIs. The way you do that is using portable class libraries is probably the first technique that you would use. I should mention, though, that portable class libraries is only available in non-Express versions of Visual Studio. So if you're using Visual Studio Express for Windows or Visual Studio Express for Windows Phone, those editions don't include portable class library. That template is just not available to you, unfortunately. I apologize for that. It's just the way it is at this point. And what portable class libraries does is it limits your APIs in that library to the APIs that are common across the various platforms that you choose. In our case, we'll choose Windows Phone and Windows 8. And so the portable class library will actually limit you to the APIs that are available to both of those. That portable class library is then compiled to a DLL that can be referenced by either a Windows 8 project or a Windows Phone 8 project, and it's used as is. And of course, as a result, it is only managed code. There are patterns. Again, we'll talk about these in a lot more detail later. MVVM is probably the best one for the purpose of Windows 8 and Windows Phone 8. It's similar to MVP and MVC, but takes advantage of data binding. And again, we'll talk more about this later. And we'll talk about what you need to do that. Again, it is an architectural pattern. There's three parts to it. There's the data model, which we talked about a few minutes ago. There's the view, which is the UI, which we talked about earlier as well. And then there's the view model, which is sort of the I guess the secret sauce, if you want to call it that, that gives you that handles all of that interaction of the UI and moving of data back and forth from the data model to the UI or to the view. The model handles the data. The view model handles the logic, either displaying that data or converting that data into the view, into a way that the view can use it. And then the view obviously handles the UI. And what you're trying to do is eliminate or minimize the amount of code that you have in your views. If you move your code into view models or into the data model, then that makes your code much more usable. Again, as I mentioned, your views are the thing that you're going to have the most trouble reusing. And so if you can move your code into view models or data models, you'll be farther along in being able to make your code reusable. Okay. We're going to go into a lot more detail around MVVM in particular. We'll give you a good grounding, a good introduction to MVVM in a few minutes. And then at the end, we'll also talk about the sharing techniques, portable class libraries and sharing and inheritance and all that good stuff at the end of the session. Before I got into that, I did want to talk about some of the platform-specific features, because if you look at it, again, visually or optically, when you think about some of these things, both of the platforms do them, and so you may think that, well, if I have an application lifecycle management that's happening on Windows Phone and and Windows 8, then I would expect that they're both the same. In fact, these things are quite different, and so we're going to talk about the similarities as well as differences between them. In many cases, you're going to have to avoid reusing code here because the features are very different. So you'll have to separate that code into platform-specific files or platform-specific code. Again, we're going to talk about that in a few minutes. The first area I wanted to talk about was the application lifecycle. And so part of the responsibility of the operating system is to manage that. It does manage things like the CPU, memory, network, battery, all of that good stuff. And in order to do that, Windows 8 and Windows Phone 8 have a very specific life cycle that they've imposed on apps that are built for the platforms. And they do that in order to maximize the experience of the end user, so the end user is not regretting installing apps and not confused by app performance because something is going on in the background that maybe they don't know what's going on. And also to maximize the device experience as well, things like battery and CPU, and all of that stuff is optimized using the application state and the state lifecycle management. And we'll talk about some of that and how that works. The OS determines what's going on based on how much memory and how much resources it has. And so things like if the operating system detects that it's starting to run out of memory, it will start terminating apps that have been pushed into the backstack, into the background, or have been suspended. So what does that mean? Well, at the very simplest, it means that only foreground apps execute code. Apps in the background are not running. They're not executing code. They are not taking CPU. They're not taking disk. They're not doing anything, right? There are exceptions to that, of course. There are certain scenarios where it does make sense for the code to be running in the background. Typical example is if I'm doing a file transfer and I want that to happen in the background because I need to retrieve files, or perhaps an even better example would be the idea of perhaps having music running in the background. Obviously, I'm going to want my music running in the background while I'm doing email or something else, browsing the web, that sort of thing. Now, if the operating system is managing the state and managing what's going on in memory, then your apps will lose unsaved data if the operating system terminates that. And so the way that you manage that is that the operating system actually gives you clues as to what's going on, and it manages that by triggering certain events in your app that you can then use to take advantage of and save your state before you get suspended and obviously before you get terminated. Windows Phone and Windows 8 are quite different in this respect. Windows Phone starts when an app starts, it gets a launching event. And then when it gets pushed into the background, it goes into a dormant state. It triggers a deactivating event, and then it becomes dormant. If you then bring it back, it uses the activating event to do that, so that you can do whatever needs to be done to bring your app back to life. If the operating system detects that it's out of memory, the app is tombstoned. There is no event. You don't see that. And so you have to use the deactivating event to save your state at all times. And then even when your app is tombstoned, you might get an activating event saying you're coming back from a tombstoned event. Or the app may just be closed and go into a non-running state. On Windows 8, it's a little bit different, and I would say it's a little bit simpler, and probably, I would say, even a little bit easier. There is no tombstoned state in Windows 8. You start off from you go from non-running to running. You get the activating event to tell you about that. When your app gets pushed into the background, you get a suspending event. When you come back from the background, you get a resuming event. And when your app is terminated, you get a terminating event. So both platforms, only the foreground app can consume CPU resources. And again, I mentioned earlier, there are some exceptions to that. You can do background tasks. We'll talk about how that works in a few minutes. It is different between Windows 8 and Windows Phone 8, so you have to keep that in mind as well. So other apps are suspended or deactivated when your app is in the foreground. So they are still in memory so that they can be brought back and sort of rehydrated very quickly. But when you are suspended or deactivated, your background, your app just stops doing that. So it stops running, and so you have to save your state. And both platforms give the app a certain amount of time from when they get suspended to when they, from when they begin getting suspended, when they get that event of suspending or deactivating, in order to save state. It's a few seconds, more than enough to save your state in local storage, and then you're put into that suspended or dormant state. So in terms of the application lifecycle, there are certain events that you have to keep in mind. In Windows Phone 8, they are all derived from the system.window.application. You get the application launching, application activated, application deactivated, and application closing. Those are the ones you have to keep in mind when you're thinking about that. And then on Windows 8, it's in the windows.ui.xaml.application namespace, and there it's on launched and on suspending. Those are the two that you have to keep in mind when you're doing that. So rather than talk about it and describe it, it's probably a lot easier if I just show you. And so let me switch back to my app. Again, I'm going to use the Contoso Cookbook app. And so let me come back to my Windows 8, and I'm going to go into app.xaml, and this is my application-specific stuff. And so I am going to put breakpoints on a few areas. So I'm going to go to on launched, and I'll put a breakpoint there. I'll go to on suspending. I'll put a breakpoint there. What's going on in there is not really important at this point. Obviously, you do want to handle that, but I really sort of focused on what are the events that are going to trigger your app to do stuff. And there is another event that you should think about, and these are things, again, they're kind of beyond the scope of this course, but things like some of the search charms that may actually trigger your app to get started, things like search or share and that sort of thing. When you use search here, I'm going to put a breakpoint on search activated. And so now that I have that, I'm actually going to run the app. And so that should get started, and you'll see that moving quickly. And you'll see it's paused there. And the reason it's paused, if I come back to, there it is. So here's my on launched event. I'm at the breakpoint. So you see my app launched, and the on launched method was triggered. And so if I continue, and there's my app. This is the standard cookbook app that's running there. If I now exit that, I'm just going to grab that and exit. And I'll just pause for a second because it takes a few seconds for the app to actually exit out. And once that happens, there it is. So there's my on suspending event that was triggered. So this is what I would see when an app gets terminated or when it gets suspended. Now, if I run this again, you'll see it's restarting. And there it's triggered again. By the way, if I look at the arguments, for instance, you can see things like previous execution state. So you can see what's going on behind the scenes and why you're getting that on launched event. In this case, the app was closed by the user. That's what I did earlier. I closed it and then I relaunched it. So I can handle all of that. Let me just continue here. And now the app is running. I'll hit the start button to come back to my start screen. And now rather than go back to it, what I'll do is search. And I'll just use my mouse here to search. And let me search for, I don't know, sugar is a good ingredient in cooking. And if I click on Contoso Cookbook, you'll see that as soon as I clicked on Contoso Cookbook was actually launched, and as part of that launch, the on search activated event was triggered. And so there are certain life cycle events that you have to manage, and that's one of them. Okay, so that gives you a sense of what the life cycle management looks like in Windows 8. Let me turn off all of those, delete all those breakpoints. And now let's have a look at the same app, although this time we're looking at Contoso Cookbook on Windows Phone 8. And again, I'm going to look at the app.xaml page. I think I have it up here already. And there's a few. Here we go. So I'm going to put a breakpoint on launching, activated, deactivated, and closing. And so if I run that, let me bring my handy dandy Windows Phone emulator that's running. It's deploying it. And so here is my app that's starting. It's loading. And in a second, you should see in the background that the launching event should trigger a breakpoint. And there it is. So there's my application. You can see it in the background there. My application launching event has been triggered. If I continue, so my app is now running. This is my cool cookbook app, the same content, and the app is now rebuilt for Windows Phone 8. That's great. But now if I hit the start button, when I hit the start button, the app will be pushed into the background. And so immediately the application deactivated event is triggered, which is great. I'm going to continue. So now the app is in the background. We did the deactivated, and yep, actually we are saving some of that stuff in the background. Now if I hit the back button, I'm at the start screen, deactivate. If I hit the back button from here, I'm going to restart that app again. And so again, I'm getting the application activated event, and we can look at the arguments and so on. In this case, you can see that the application instance is preserved. That means it was still in memory, hadn't been terminated yet, which is pretty obvious. There was nothing else running, and so there's plenty of memory for it. Let me continue here. And now the app is running again. Now the app, rather than hit the start button at this point, I'm actually going to hit the back button, which means I'm going to exit out of the app rather than push it into the background. And so I should get a different trigger. And there it is. There's my application closing event, if you can see that there. My application closing event is triggered because now I'm actually exiting out, and of course I have all my arguments there if I need them. So that sort of gives you an idea. Again, let me just turn off all of these breakpoints so I don't see them later. That gives you an idea of where we are with application lifecycle. Now, rather than continue on, I think we have about a minute before the next break, so I think I'm going to stop there. Frank, does that sound all right?
Yeah.
I think this is a good place to stop. We're going to continue back. When we come back, we'll look at system tasks and contracts and that sort of thing. We'll take a 10-minute break, and we'll get started again right around, what time, Frank, around 9 or so?
10 minutes.
In 10 minutes. We're going to start in 10 minutes from now. So go and get your preferred hot beverage, and we'll be back soon. All right, and we're back. Hopefully you got a coffee and we're ready to keep going. So we talked about the UI stuff, we talked about data models, and now we're sort of in the middle of going through some of the platform-specific features and comparing Windows 8 and Windows Phone 8. Now, I'm told that one of the questions that's been asked a few times is where can we get the source code and so on, and I did mention there was some resources, and so I'm kind of forward referencing some of the stuff I was going to talk about at the end. And so if we look at this slide here, this is the additional resources. I've actually created a bit.ly bundle, and you can get to it at bit.ly, so bit.ly/build for both, with a capital B, a capital F, and a capital B again. If you go there, you'll see a whole long list of links that you can get to, and that should include the source code. It also includes links to all sorts of interesting stuff that you should keep in mind. And so it's a really good sort of a go-to resource when you're looking for, or when you're thinking about building for both Windows 8 and Windows Phone. Okay, so let's get back to, let me just switch back to my other PowerPoint and continue where we had left off. And so we had just seen, last week's episode, we had just seen the application lifecycle, and we'd gone through a demo. And so now we're going to continue on and look at some of the other platform-specific features and compare and contrast those between Windows Phone and Windows 8. There is some built-in support for common operations in both Windows 8 and Windows Phone. In Windows 8, they are called contracts. In Windows Phone, there's something that's similar called tasks, although the developer experience is quite different. So you might call me on comparing those two, but they sort of try to do the same sorts of things. And so I in my mind, I sort of, if I am doing contracts, some of the things that I would do with a contract, I would do with tasks. And so it basically involves coordination of stuff that your app needs to do with the operating system. So the task approach, Windows Phone APIs are found in the Microsoft Phone.tasks namespace. So things like the photo chooser task, email address chooser task, save a contact task. There's a whole slew of them. There's probably 20, 30, maybe more tasks that are available. And so between tasks and choosers, you have a bunch there. Windows 8 has a number of individual APIs that are collectively referred to as contracts. And basically, you, by defining and declaring those contracts in your manifest, you're basically telling Windows that you are going to adhere to this contract to do things like sharing or searching or play to or any one of the other contracts. And these tend to be related to what you would normally see on the charms bar, so things like, as I mentioned, search and share and so on. The Windows 8 contract is essentially an agreement, as I said. It's an agreement between your app and the operating system that when the operating system wants you to do something, it expects you to do it in a very specific way, and you implement that in that very specific way. Implementing the contracts means you override certain methods in the application class, or you handle certain events in various classes. And depending on the app, the user may actually expect some of those contracts to be there. And so certainly I would encourage you wherever possible to take advantage of the contract. It just makes your app feel more like a native Windows 8 app, and so you should take advantage of that. So the typical ones, search and share, are the two that you should be looking at, absolutely. Settings is another one, Play To is another one, and so on. The other area, and this is sort of the, I would even call it the defining feature of both Windows Phone and Windows 8, is Live Tiles. And Live Tiles are the entry point for both Windows 8 and Windows Phone 8 apps. And so your primary tile is what would normally launch your application. Now, of course, Windows 8 also has the app list, but for the most part, the live tile is what your end users will see as sort of the entry point into your app. There's also the concept of secondary tiles, where rather than starting an app, you're not only starting the app, but manipulating the app via the data within the app, if that makes sense. Both platforms, both Windows 8 and Windows Phone 8 support live tiles, and both of them support secondary live tiles. And both of them support the idea of periodically updating the tiles so that they appear live and interesting and are a clue to the end user to come back and start your app again. Again, if there's any way that you can do that in your app, certainly from what we've seen, apps that take advantage of live tiles tend to get downloaded more, tend to get used more, and tend to get preferred over competitors that don't have live tiles. So it's a good way to get more downloads. Again, both platforms support tiles, but the APIs are completely different between the two. And so unfortunately, it's pretty hard to reuse live tiles, either the tiles themselves or the code that you would do that. So let's look at how they're different. On Windows Phone side, there are actually three sizes of live tiles. There's the small, medium, and wide live tile. These are new to Windows Phone 8. We used to have just medium. Now we have small and wide as well. Windows tiles, there's only two sizes. There's medium and wide. In Windows Phone, you have several templates that you can define for your live tiles. And the standard ones are flip tile, cyclic tile, iconic tile, and then there's this just standard tile where you define exactly what you're doing. On the Windows side, secondary tiles are defined and customized by XML templates. And so it's a little different in the way you do that. You provide tile images in the manifest in the Windows Phone side. It's the same way on the Windows side, so that's one similarity. You can create secondary live tiles using a static method, the shelltile.create in Windows Phone. On Windows, you use a secondary tile.requestCreate async. Again, totally different API there. And then updating the app tile on Windows Phone is done using the shelltile in the Microsoft Phone.shell API. And in Windows, you use the tile update manager and tile notification in the windows.ui.notification namespace. So again, totally different. One other area that you should keep in mind is that on the Windows side, the end user can actually turn off your live tile and turn off notifications so that your live tile, even if you have one, and even if they've pinned it to the start screen, if the end user decides they don't want to see a live tile on your app or on any other apps, then they can turn that off. So it's something you need to keep in mind, and you need to check for that before you try to update your tile. So let's look at the differences there. You can see here the comparison of a secondary tile creation. So here we're using a cycle tile data, so it's the cycle tile template. and we're giving it a title, we're giving it the background image using a URI, and giving it a list of images that it can cycle through as part of the cycle images. The cycle image template is the same one that you may have seen as it's the one that the photo app uses to cycle through. I think it has 8 images that it cycles through. So that's how you define the template, or what your tile information is, and then you use the shelltile.create, give it the URI, give it that tile data, and the operating system that goes off and creates that for you. Windows, it's actually a little bit easier. You new up a secondary tile, give it a unique ID that it can be referred to as, a short title, a long title, activation argument, and then there are some options that you can define. In this case, we're showing the name on the logo, and then giving it the URI to the image, to the logo of the tile, and then you use the request create async method to create that tile. So you can see they're completely different in the methods that you're using to create those. And so, again, it makes it a little bit more difficult to share code among those two. Another area, and this is sort of tangentially sort of similar or related to tiles, is the idea of notifications, or notifying the user. It's another way of you getting in front of the end user and telling them that something needs to happen, or that they need to take some sort of action. You alert the end user to that using notifications. In Windows Phone, you also have the concept of reminders. We'll talk about those as well. The one thing I would caution you if you are using these is try not to overuse them. They are very intrusive. They basically get in your face, and if you overuse that, the end user may get annoyed with your app and turn off your notifications, or worst case, they may actually uninstall your app. So use them sparingly, and when you are using them, make sure that there's actually some real action that the end user should be taking, or some important information that the end user has asked you to give them. And even within your app, you should give the end user the option of turning these notifications on or off, so that, again, they're not tempted to go and uninstall your app. Notifications, Windows 8 supports 2 kinds of notifications. There's reminders and alarms. These are ways of bringing information to the foreground so the end user can see it, and this would be in the foreground even when your app is not in the foreground. You can also use toasts to do that, using the shell toast, and that again can be shown from the background. The alarms and reminders are in the Microsoft.phone.scheduler namespace, and shell toast is in the Microsoft phone.shell namespace. Windows 8 uses toast notifications, and it's a little bit simpler. You use the toast notification manager and the scheduled toast notification. You have to enable these in the manifest, and I'll show you how to do that in a second. And you have to give it a template. I think there's 7, actually I think there's 8 different templates that you can use, and they're basically defined in XML, and you choose one and then hand that to the API call, and it handles creating that toast for you. Okay, so let's actually have a look at that. I'm going to switch to Visual Studio here. And so again, we're going to use the Contoso Cookbook. Let me start in Windows Phone this time, and I will go to Common. Here it is, features.cs. And here you'll see that there is a set reminder API or method as part of my notifications class. And so let's just walk through this quickly. It's actually pretty trivial. This gets called when you tap the reminders on the app bar, and it's actually a toggle. So the first thing I do is I check if there already is a reminder scheduled, and I'm calling this method, then it means the end user wants to turn off the reminder. And so you can see here where I'm actually using the remove method to remove that reminder. But let's go through how to create a new reminder. So I'm checking to see if it exists. If it does exist, I'm removing it. And then I am I'm newing up a reminder, giving it a unique ID so that I can find it later and check for it later, giving it a title, giving it some content. In this case, it's a reminder for a cookbook app, and so it's a reminder. Typically, you would click it when you want to set a reminder because you put something in the oven or something like that. And so that reminder would come based on the amount of preparation time for a particular thing. And then this is some debug code. So if I am using the debugger, rather than having to wait 30 minutes, it just uses a begin time of 1 minute. Basically, it's telling me that the reminder will be 1 minute long, or 1 minute from now. Or if I'm actually running the code in production, then it's actually getting the item prep time and using that to set the reminder time. And then there's the begin time, there's the expiration time. There's a recurrence type. In this case, there is no recurrence, but I could set it to be a daily recurrence and so on. That's not something you would do in a cookbook app, but obviously something you might do in a calendar app, for instance, that sort of thing. And then there's a navigation URI. The navigation URI is important in that in Windows Phone, when the reminder comes up, if the end user actually taps the reminder, it can actually relaunch the app and bring you directly into a particular page, deep linking directly into a particular page in the app. And so it can actually launch the app and bring me to that recipe so that I can continue doing what needs to be done. And so that's kind of handy. It means that when I get the reminder, I can take action on it right away. And then once I've created that reminder, then I basically use the scheduled action service to add that reminder. And then there's some interesting stuff here. This is more related to the in-app purchase. We're not going to talk about that today, but that's generally it. And then, as I mentioned, there is because it's a toggle, the scheduled action service, the same way we use the add to add the reminder, there's a remove to remove the reminder, and it's the same thing. It's just basically removing it. So that's how you do it in Windows Phone. Let's have a look at how you would do a toast notification on Windows 8. So let me switch over here, and I will go to the item detail page, and let's see. There should be an on reminder. There it is. I missed it. Okay, there it is. Okay, so the on reminder button clicked, and so here it's an app that's a cookbook again. When I click the reminder, it will basically set a toast reminder that will then get shown when that event is triggered. So I'm using the notifier, Toast Notification Manager, to create that Toast notifier. Making sure that notifications are enabled. Remember, I said this earlier, the end user may have, let me just show you here. If I dive in, you can see this notification setting. It can be disabled for application, disabled for user, disabled by a group policy even, or disabled in the manifest. You may have actually forgotten to turn it on in the manifest, in which case it's just never going to trigger, because if it's not in the manifest, then you can't run that code. So I'm checking for that, and if it does do that, then in this case I'm just popping up a message dialog that says, sorry, I know you want a notification, but I can't do notifications because they've been turned off for whatever reason. But if I can, then I'm creating a toast template. Remember, I said there were, I think, 8 different templates from toast from 0 to 8 of one sort or another. The toast text 1 template is a very similar. Again, I think I can dive in and show. Yeah, there's the 8 of them there. There's different kinds of templates based on how much text you want and whether you want the text to flow across 3 lines, or you want a title with 2 lines, or just 3 separate lines, whether you want an image on the left or not. And so you decide that, and once you've decided that, you choose that template. In this case, I'm using the Toast Text 1, which is essentially text that flows across 3 lines and then gets clipped. And so I am checking the element. I'm adding the reminder to that, and then I'm scheduling it. So here I'm checking I'm defining the date of when I want that to happen. And then I'm doing a scheduled toast notification, calling it STN, giving it the template and the date, And then once I have that scheduled toast notification, once I've newed that up, I just hand that to the notifier with the add to schedule method. And then and then in this case, 30 seconds from now, I will see that toast pop up. So pretty straightforward. I should show you that there is a, let me see if I can find the, here it is, package. Oh, I had it open already. Here's my manifest, and you can see here that in the badge logo, there is toast capable. Right, so here I'm telling the app whether I am going to allow, I'm telling the operating system, I am asking the operating system to allow me to do toast. And so this is something that is used by the operating system. It's used by our certification team. When you submit the app, we verify that. You're not doing it. Toasts without having that in the manifest and so on. And then of course the end user sees that when they install your app, they see that you're requesting that toast capability, or in this case, toast capability. And so if you are doing toast, make sure that you set that toast capable to yes. It is actually no by default. And so if you want to do toast, you have to go in here and do that. Okay, let's go back to PowerPoint and continue on our journey to comparing the various system level stuff in Windows 8 and Windows Phone 8. So we talked about local storage earlier. One other thing that's also important is app settings. And so there are contracts for settings, but there is also a place where you want to store your settings. And unfortunately, there is no overlap between Windows 8 and Windows Phone in terms of how you do that. So when you allow your end user to choose your preferences, in Windows 8, you would use the application data class to manage settings. That's in the Windows.storage namespace. And as I mentioned earlier, you do have Windows.storage on Windows Phone, just not the application data class. So you can't use that to store your settings. On Windows Phone 8, you have the isolated storage settings class that you would use to manage your settings, and that is in the system.io namespace. And so it is quite different here. This shows a method that can save a setting to either local or remote storage. This is in Windows 8, obviously, because you can, you can do local or roaming of settings in Windows 8. You can't do that in Windows Phone. And so if I am passed the Boolean that says if it's, whoops, let me back up there. If it's local, then we will use the local settings.value key and give it the value. If it's roaming settings, then I'll use application.data.current.roaming settings.value key and then value. Windows Phone is quite different. You use the isolated storage settings, as I mentioned earlier. So here we're defining that, giving it the setting key, which we're calling music setting here. It's the in the constant music key. And then I have this property that has been set up here, and when I get that, it goes and retrieves it using the application, isolated storage settings, application settings, and retrieves that. And when I'm setting it, then again, I'm using app settings, the isolated storage settings, to actually save that to my local storage. So pretty straightforward. It's actually quite easy to do in both cases. It just happens to be quite different. And so when you are building a Windows Phone app or a Windows 8 app, you'll just have to manage that in two different areas. And we'll talk about how you do that later, or how you can separate the various system-specific things between Windows 8 and Windows Phone towards the end of the course later on today. Networking is also another area. I mean, obviously, apps are going to pretty much rely on the internet. We think that internet thing's going to catch on, so it's a good thing. So Windows 8 and Windows Phone, you need to declare that in the manifest. And so it's just a capability that you turn on. On Windows Phone, it's ID_cap_networking. And in Windows 8, it's in your package manifest. It's just the internet client. And that one's actually on by default in most of the templates on Windows 8. Now, there are a number of differences. There are some things that are the same, but there are a number of differences, unfortunately, when you are using the networking APIs. You can take advantage of some of the similarities to abstract that out, but we're going to talk about some of the differences here. So Windows 8 actually introduces a cool new API called HTTP Client, quite useful, and it acts as a session to send requests to the server. So whether it's a get, post, put, whatever you need to do, and data is returned as a string, and it's all done via async, and so it's all good. And you can also do authentication using the web request handler if that's required. On a Windows Phone, this is not available on Windows 8. There's something called Web Client. On Windows 8, this is not available, but you do have something equivalent. You would use the HTTP client, which we just talked about. The web client is slightly different from what you may have seen in earlier versions of Windows. Here we have the example down at the bottom of the screen here where I'm newing up a new web client and then setting the anonymous method there, and then downloading the string and then showing the results once that's done. So pretty straightforward, but not at all like it's done on Windows 8, and so you'll have to manage that between the two platforms. Now, we talked earlier that only one app at a time, whether it's Windows 8 or Windows Phone, can be in the foreground. That's not actually true in Windows 8. You can have two apps in the foreground if you use a snap view and a filled view. But for all intents and purposes, you have an app or two that's in the foreground. But there may be some pretty interesting scenarios where you may want to run code in the background. Those, for example, include streaming of music. So if I want to listen to my MP3s when I do that, or let's say I want to retrieve some files from a server for updating my application in the background, updating my cache, what have you, or if I want to download a file for whatever reason, I may want to do that in the background. Both Windows 8 and Windows Phone give you the capability to do that, and they both run on a specific trigger, and they behave independently from the app. So in other words, your app has a foreground portion to it that is what the end user would see, and then you would also define a background portion to it. The operating system has complete control over when your background task is run. And so let's look at the differences between Windows Phone 8 and Windows 8 background tasks. If we look at Windows Phone on the left and Windows 8 on the right, Windows Phone 8 tasks derive from the background agent or one of its subclasses, Microsoft Phone and Microsoft Phone.Scheduler namespaces. You basically override the onInvoke method and then call the notify complete when you're done to let the operating system know that your background task is done and they can move on to the next background task. You should always check that your background task is not already registered, and if it is, you deregister and then re-register. I'll show you how that works in a couple of seconds. And you would use the scheduled action service to add or remove background agents once you've defined what they're doing. Windows 8 is a little different. You're using the Windows.application-model.background namespace. You implement the iBackgroundTask interface and its run method, and then you declare the background tasks in the manifest. Again, that's another capability that the end user gets to see and gets to accept as part of downloading and installing your task. Again, you check that your task is not already registered, and then use the background task builder to create and register an instance of your task. And then you make sure that you handle the background task completed in order to get data back from whatever that background task was doing. So let's look at a couple of examples here. This is the Windows 8 example here where I have a simple background task that's implementing the iBackgroundTask interface. And so here, I'm overriding the run method and I'm doing stuff. And then of course there's also in my manifest, there's my background task there. So when that's running, you'll see here that I am defining or I'm checking to see if the task has already been registered, and if it is, usually I would deregister it and then re-register my new task. If it's not running, we then continue and create my new using the background task builder API, and then give it a name so that we can refer to it and find it again later. Give it a task entry point, set a trigger as to when I would want that, and then I would use the register API to register that. And then I would also set my completed method, so I know that when the background task is completed, I have an event handler that gets triggered so that I can do whatever needs to be done once that background task is complete. Don't know what that might be, depends on whatever scenario you may have defined in your case. Windows Phone 8 is a little different. You would override the onInvoke method and use the schedule task agent here. And so here I would write some code, and when that background task is complete, then I send a notify complete. That notify complete method tells the operating system that you're done with the background task, and so the operating system can go on and use the CPU or the thread for something else. And so here I'm defining that task. So I am somewhere in my code, in my foreground code is where I would launch that task. So I'm using the scheduled action service to find that background task to make sure that it's not already registered. If it is, if it's not, rather, then I'm newing up a new one. If it is, then I remove it. And so then I create my new task with the description, whatever that might be, the expiration time, in other words, how long will that task run for, and then I would add that using the scheduled action service, and then the task will run based on whatever the operating system decides. On Windows Phone, for instance, it runs every 30 minutes for a certain number of seconds so that you can do things in the background on a regular basis. So again, pretty easy and straightforward to do. There are certain scenarios where they might be a little different, streaming, for instance, or VoIP or that sort of thing. But for all intents and purposes, it's quite straightforward, but it is very different between Windows Phone and Windows 8. And so you have to keep that in mind when you're building your app, and you have to isolate that platform-specific code to the specific projects that are specific to that platform. And obviously that can't be reused. The other area is in the media capture area. Obviously, both Windows 8 and Windows Phone 8 have media capture APIs, where I may want to take a photo, for instance, and then whether that's on Windows 8 or Windows Phone 8, there are capabilities to do that, and they're different, unfortunately, between the two. They both have capture APIs that you can use, and then there's also system-provided UIs that you can take advantage of, and we'll do that in a few minutes. So looking at the media capture UI in Windows 8, Windows uses Windows 8 uses the camera capture UI to capture images and video, and basically you would have to declare that again as a capability in your manifest, both the webcam and microphone capabilities. And once you've done that, it's actually pretty straightforward. You new up the camera capture UI, and then tell it, and then you use the capture file async, and then tell it where you want to put it, and then it comes back and gives you that file, and then you can do something with that file, whatever that might be. Save it to disk, display it on screen, what have you. Windows Phone uses a different API. It's again, it's a task as part of one of the tasks, one of the chooser tasks. It's actually the camera capture task to take photos. And again, you have to declare capabilities. It's the IDCAP ISV camera and IDCAP _camera phone in the manifest. If you want to do videos or capture a sound. And so here I am declaring a camera task. Here's my initialization, where I am newing up the camera task and telling the camera task when it's completed what to do with that, and that's then calling the photo captured method. And then at some point, the end user triggers a take photo. Perhaps they click a button, an app bar button, or something like that. And so the camera task.show is what would trigger that system UI. And then once the end user is done, it comes back and it comes back and triggers it runs the photo captured method, and then you can do whatever it is you want to do with the result. Again, save it to disk or display it on screen or what have you. This is kind of neat, so let's actually go back to Visual Studio and have a look at how that works. And so let's start with, go to Windows 8 here, and we will go to the item detail page and go to here it is, on capture photo. So in my API, I have something that triggers this, and so obviously what happens, as I said, is I'm capturing camera capture UI. It comes back with in this case, it's a photo. I'm telling it to go into photo mode, and so it's going to come back with that file. And then if the file is not done, then we're going to do something. In this case, we're going to use the data transfer manager, which is what we use when we're using the share API. And so it's going to trigger that, and it's going to launch the share UI and allow me to share that with some of the other apps in the operating system. So apps that have already been installed that have implemented the share target contract. Let's actually run this and see how that works. So this is the cookbook. And so let me go into one of the recipes, and let me just open it up. You can see there's an app bar button called Brag. And so I am going to take a photo. And so normally, well, actually, it's giving me the option of photo or video. I'm going to use photo, which is the one we just looked at. Normally, I would be taking a photo of the recipe I've just cooked so I can brag about it. In this case, I'm just going to take a photo of myself. And there I am. And so you can see that there's some system-provided UI. I didn't have to do anything other than do that. And so things like cropping, for instance, is all provided for me, and so I can crop this, click OK. Now I would click OK. Remember, we're using the Data Transfer Manager to trigger a share, and so it should come back with that file, and then it should, there it is, it should trigger the share. And so I can do something with that. I can send that to Metro Twit, for instance, and just tweet that. There's my video, and so and if I send that tweet, for those of you that are following me, you should see that tweet along with the photo. Now let's have a look at how that might work in, let me close that and come back to Visual Studio and have a look at how something similar to that would work in Windows Phone. So if I come back to Windows Phone, let's look at the recipe detail page. Similar idea here. Actually, it's a recipe detail page. And here it is. And let's see. Oh, here it is. Okay, so right up at the top of the recipe detail page, you see there's a camera capture task. So I'm making that available. I'm making that available as part of my class. And then you can see in the constructor, I am actually doing something with that. I'm creating a new camera task and putting that into camera. And then I'm also telling it that once you're done with that, there's the camera completed. And so if I go and look at how I trigger that, there's a button take picture, here it is, button take picture click event. And so here it does that. And so basically it takes that camera object or instance that I've just created, sends the show method, and then that is going to trigger the system provided API. And if you remember, I gave it a camera completed, and so when I'm done with that, I can do something with that. In this case, I'm going to display the photo on the page, in an image control called My Image. So let's actually run that, and again, we should see this. It's pretty straightforward. Okay, let me see, find a recipe here. There's some, there's just some in-app purchase stuff that's in that, in this app. When you look at this app, it's actually quite nice. It's a good way to learn how to put in-app purchase in your apps. But in this case, I just wanted to get to the recipe so that I could take the photo. You can see I clicked the photo. Now, because I'm using the emulator doesn't use the webcam to take a photo, so it just gives me an image that's animated and showing me something. And if I click on that, it will take that image and then give it to me. And if I accept that, it brings it back, and it should be somewhere. There's my pictures there where it adds it to my pictures. So again, pretty straightforward, but again, not the same between Windows 8 and Windows Phone. So you have to take that into account when you are doing that sort of thing. All right, let's go back. I think we had one more section to talk about. Whoops, wrong PowerPoint. Right, the last section that I wanted to talk about is the app bar. And the app bar is, again, very similar capability or similar idea or concept between Windows Phone and Windows 8, but implemented in very different ways. The app bar is where you would implement certain very specific and common commands that you would have in your app. And typically, they would be actions that you would be doing against whatever content is on the screen at the moment. Using the Windows Phone Windows Phone application bar, and the app bar in Windows 8, you have different things that you can do in your app bar. You have more room, so you can be more creative. There's very little that you can't do with the Windows 8 app bar. It's basically a container, and you can do pretty much anything you want there. The phone, though, does have limited screen space. You can only put 4 commands or 4 buttons on the app bar, and as a result, there's not too much you can do with that. You can add additional menus. I think 6 or 7 menu items that you can add below the app bar, but it's a little bit harder for the end user to find, and so typically you want to limit the number of commands that you would have in a Windows Phone 8 app to the ones that are the most essential ones, or the ones that the end user would see most often. Let's compare how those look. So again, Windows Phone 8, there's one app bar at the bottom of the page. Windows 8 has 2 app bars. There's one at the bottom of the page and one at the top of the page. Windows Phone is very restricted and very structured. Every app bar can have up to and no more than 4 items on the app bar. Anything above that would be put on the menu. There's no way for you to group those items. It's very restrictive, right? It's 4 buttons. They're round buttons. You can do whatever you want with those round buttons as long as you're putting 4 round buttons on there. Windows 8, on the other hand, the app bars behave like containers. There is no standard menu that you can use like the Windows Phone app bar, but you can do similar things using flyouts and so on. You can also group items using nested containers within the app bar. And so you can be more creative, you can do things a little bit differently and take advantage of that. And typically, it's not a requirement, but what we're seeing mostly is that on the left-hand side of your app bar in Windows, you would typically have screen-specific tasks, and on the right-hand side, bottom right-hand side, you would have global tasks for the app. And also along the top of the app bar, along the top, you would typically use for navigation purposes. For instance, in IE, you see that when you're looking at different tabs, you would be using the top app bar to have the different tabs displayed, and so the end user can switch back and forth. The application bar control is what it's called in Windows Phone, is within the phone application page .application bar namespace, and then the app bar control in Windows 8 inside the page.bottom app bar or page.top app bar. You can set mode to default to show the app bar when the page loads on Windows Phone side. On the Windows 8 side, you set the is open property to true to show the app bar when the page loads, and set is menu enabled to enable the menu, and you can use is sticky to force the app bar in Windows 8 to show and to always remain open rather than forcing the end user to swipe up from the bottom or right click on the screen to bring that app bar with the mouse. Let's look at the XAML for that. In Windows 8, you'll notice here there are two stack panels that are used to group the buttons. I have one group along the left. You can see that I'm using horizontal alignment left there, and I have an edit, remove, and add button along the left-hand side. Again, those would be, as I mentioned, typically the guideline there is to use the left-hand side for tasks that are related to what's going on the screen. And then on the bottom right, you can see here my stack panel, horizontal alignment right. I have a refresh and a help app bar button. And those are more global actions that the end user might take. On Windows Phone 8, it's a little different. The application bar you're setting the properties via XAML. So here is visible, it's true, is menu enabled, true, what mode, whether it's default, the opacity, and all of those things. You can also have then various application bar icon buttons, and again, you can have up to 4 of those. And the operating system decides where to put those. It'll center them based on how many there are, and it will space them accordingly. And so here I have 4 of them, one for taking a picture, one to share, one to start cooking, perhaps it's an alarm, and then one to pin my app or maybe my recipe to the start screen. So I'm going to stop there. Let's just do a quick recap of what we've done. We've sort of taken a romp through Windows Phone and Windows 8, trying to compare and contrast those two platforms. We did look at the major differences. If you remember back to when we first started this morning, the differences between the physical devices that end users see when they are interacting with those two different platforms, and they are quite different, and as a result the user interface and the user experience between those two platforms are quite different, and my recommendation to you is not to try and reuse your XAML between those two platforms. But there are other areas where you can take advantage of similarities in the platform so that you can reuse code. In particular, you can use things like portable class libraries, and in areas such as, for instance, the data model, which we talked about earlier, when you're storing using the Windows Storage API or storage file in the Windows Storage namespace for file storage. That is the same between Windows Phone and Windows 8, Windows Phone 8 and Windows 8. And so you can reuse that by using things like portable class libraries. And there are many features that externally you would think are very similar, but actually are implemented quite differently. The developer experience is quite different. The user experience may be different. And so things like application lifecycle, tiles, media capture, tasks and contracts, all of those things are different. And so they're implemented differently. And so you need to think about that in a different way. So we're going to stop here. I think I have a question from the queue that Frank has queued up for me here. How can we set the periodic update of live tiles? So typically, you would do that using a background task. And so the same way we talked about background tasks earlier, you could do that on the device. The background task is triggered every 30 minutes. And so what you do with that is up to you, and typically and very commonly, you would update your live tile within the background task. You can also do that on the server side. As you can imagine, you can actually trigger a notification to come from your server to the device if you register with the notification service. And then the server can send that notification anytime. And so if you have a notification service, you're not limited by the operating system deciding when that live tile gets updated. You can actually do that on a more frequent basis. So for instance, if you are doing things like updating a news app, and you might want to trigger a live tile to change if there's some breaking news, that would be more immediate and more appropriate, I think, if it was coming from a server. Your server would be checking for a trigger, in this case breaking news, and if there was breaking news and the end user had registered an interest in that, in wanting to get that as a live notification, then you would do that by a live notification via the notification service. I think I have time for one more question. Different app bars for an application, different buttons on one page than another. Yes, to both of those. You can have different app bars for application. You can have different pages may have different app bars. It's a very common scenario where, again, typically what you see on the app bar are buttons that give you commands or actions that you would take on the content that you're seeing on the screen at the moment. And so if the application page is different, then the app bars would be different. And so you would change the app bars based on the application page. And of course, the different buttons on one page and another. That's obviously something that you would do. So I think we're out of time. We're going to stop here. I think we're right on time at this point. We've actually spent the past 2 hours talking about Windows 8 and Windows Phone, comparing and contrasting those two. We're going to spend the next 2 hours talking about how you can reuse your code. We'll talk about how you can build view models to move some of your code that you may have in your code behind in your views into a view model that can then be reused across platforms. We'll talk about MVVM and how that's useful. And then finally, at the end, we'll talk about, once you have all of that built, how you can use some techniques to share that between Windows Phone and Windows 8. So stay tuned. Go grab yourself a coffee. I'm going to do the same, and then we'll be back in about 10 minutes.